Ever pondered why pressure switches hold such significance in a plethora of industries? Well, these ingenious devices are pivotal in monitoring and controlling pressure levels. By detecting changes in pressure, they can actuate or deactivate electrical circuits, thereby ensuring the smooth operation of various systems. First up, we have the diaphragm pressure switch. This switch utilizes a flexible diaphragm that reacts to pressure changes. When the pressure escalates to a certain threshold, it triggers the switch mechanism, opening or closing the electrical circuit. Next is the Bourdon tube pressure switch. This switch consists of a curved tube that either straightens or bends as the pressure fluctuates. The tube's motion is then transferred to a switch mechanism, which activates the electrical circuit once the pressure level reaches a predefined point. Then we have the bellows pressure switch. Using a collapsible metal bellows, this switch responds to pressure fluctuations by expanding or contracting. Once the bellows reach a specific threshold, it activates the switch mechanism, thereby controlling the electrical circuit. Moving on, we encounter the piston pressure switch. This switch houses a movable piston that reacts to pressure changes. As the pressure soars, the piston moves to actuate the switch, and as the pressure plummets, the piston reverts to its original position. The differential pressure switch is another type. This switch monitors the pressure difference between 2 points. It finds common use in filter systems, ventilation systems, and industrial processes, indicating when there's a clog or excessive pressure drop. Next in line is the vacuum pressure switch. Tailored to monitor and control negative pressure or vacuum levels, these switches usually have a different range and operating mechanism compared to standard pressure switches. Last but certainly not least, we have the electronic pressure switch. This switch employs electronic sensors to detect pressure changes and generate electronic signals. These switches offer accurate measurements, precise control, and digital display capabilities. These are just a few examples of the different types of pressure switches. Variations exist within each type to meet the specific requirements of different applications. Choosing the appropriate pressure switch hinges on factors such as pressure range, set point, fluid compatibility, and environmental conditions. So, in a nutshell, whether it's a diaphragm, Bourdon tube, bellows, piston, differential, vacuum, or electronic pressure switch, each plays a pivotal role in various industries. Their functionality, while differing in approach, all center around monitoring and controlling pressure. Remember, the right choice of a pressure switch can make a world of difference in ensuring smooth, safe, and efficient operations.